everyone, welcome to the online video tutorial series of Computer Network subject. In this video, I will explain how the TCP connection is established and how the congestion control is maintained by our TCP protocol. I am Jishan Seth, Assistant Professor in IT SAP Department of LJ Institute of Engineering and Technology. So let's start with today's topic, how the TCP connection is established and disconnected. So basically, when we are talking about the connection establishment, where the TCP is doing this type of task, we can consider this task in the form of handshaking. So TCP is basically performing the connection establishment and connection release phase in three-way phase. That's why it is known as a TCP three-way handshaking. So that is the first topic. After that, I will explain about the congestion control mechanism with context of TCP and what are the terms related to performance if we are talking about the reliability in transport layer protocol. So let's start with our first topic, TCP connection establishment. So when we are talking about the connection establishment, TCP is performing multiple steps before transferring the data. So what are that steps and which algorithms are used and which are the terminologies are used? So when we are talking about the TCP, it provides a reliable communication with something called the positive acknowledgement, or we can say that it is a retransmission. So that will be covered in the previous video. So when we are performing the connection establishment, then some flags are used here step by step. So we learn all that flags step by step. So first step is all about the synchronization sequence number. So when client wants to establish a connection with the server, so first client is initiating this step number 1, and it sends a segment, that is a small part, with synchronization sequence number, which informs the server that client is ready to communicate with the server. So this is the first step. Using that, client is initiating and send one message. That message is known as a synchronization message. Now step number 2. So when server is successfully received the synchronization message, then after in the response it will give the synchronization plus acknowledgement. So what happened here? Server is response to the client with sync plus acknowledgement signal bit. So what is acknowledgement bit here? So here acknowledgement is signifies that the response of the segment it is received. So which segment is received by the server here? Synchronization message in step number 1. So in the response it will send the acknowledgement. It tells that I am successfully received the synchronization message of the client, and also send some sequence number that is expected in the next frame. So in the step number 2, server is sending two signals here, synchronization signals and acknowledgement signals. Now step number 3. So after receiving the particular signals from step number 2, here client is acknowledged that particularly sync message and acknowledgement message is successfully received by the client. So that's why it is considering by the step number 3. So here we can say that after step number 3, both the parties, client and server, are reliably connected with each other, because both the parties here getting the acknowledgement here. So if acknowledgement is not received by any of them, then we cannot say that reliable communication is going on. But in three-way handshake, up to the step number 3, both the client and server are ready to communicate with each other here. Now in step, let's see the particular figure here. Host P and host Q is available. So what the steps we are just discussing, it is denoted in this particular step. So host P wants to communicate with host Q. So how these particular steps are performing here? So here in sender side we can say that it first initiate the sync message, that is the telling the sequence is equal to X. Now after the first step, what happened here? Server is successfully received the particular sequence number, and in the response it will generate two message signals. That messages are sequence number plus acknowledgement number. Now when client is successfully received this message, in the response it will send the particular acknowledgement. Acknowledgement is telling that I am successfully received the particular acknowledgement, and the next frame that it wants to send. So this is the basic step how the TCP connection is established. Now we are talking about the how the connection is terminated. So after the step number 3 of the our connection establishment, data transfer will be executed. But when the client is initiated that I want to terminate my particular process, either both the side, anyone can terminate the message. But in this scenario, we will discuss about the if client wants to terminate the connection, then which step will be followed. So here again all the number of flags and signals are sent by the client and receiver. So what are that particular signals? Let's learn one by one. So first is all about the finish, FIN. So FIN from client. So that means here client wants to terminate that particular connection because it doesn't want to more communicate with the server. So at that time client application is decided it wants to close the connection and discloses that TCP segment with the FIN finish bit is set and that will send to the particular server. So that message is written like a FIN underscore wait underscore one state here. So here after sending FIN message, client is waiting from the response what the server is now in future message is responding. Now in step number 2, what happened here? So in step number 2, server is after receiving the FIN message, server is immediately sending the acknowledgement message here. So this is all about the acknowledgement that I am successfully received your message. Till now server is not telling that I am closing my connection, but server is acknowledged that I am receiving your finished message and in future I am ready to close this connection. So after receiving the step number 2 acknowledgement message at the client side, client is understand that in future I will definitely close my connection here. Now we are moving to the step number 3. So till now client is waiting that how the server is in future end my particular session here. So while a FIN underscore wait underscore one state is going on after step number 1, the client wait for a TCP segment from the server with when it will receive FIN underscore wait underscore 2 state here. Because when client is sending one FIN underscore wait underscore 1, that means here client is initiated with sequence number 1 here. So when it receives the sequence number 2, that means server is closing all these sessions with the client. But till now, till step number 3, it will not receive that. Now we are moving to the step number 4. So in step number 4, the FIN message from server is sent here. So server is now ready to close the connection for this particular client. Then after it will send FIN message and it will wait for that client is sending the acknowledgement from this particular FIN message here. So in step number 4, we can say that client server is sending the FIN message and telling that now I am ready to close your connection. And in step number 5, client is sending the acknowledgement that I am receiving the finished message and I am closing the connection now. So in step number 4, acknowledgement is sent by the particular client here. So what we are discussing for this particular signals is denoted in this particular figure. Step number 4, sorry, step number 1, client is sending the FIN message here using the signal FIN underscore wait underscore 1. Now after receiving this acknowledgement, sorry, FIN message, server is sending the acknowledgement that I am successfully received your particular FIN message. Now in step number 3, particular client is on the waiting mode. So which waiting mode is there? Already it is sending that particular message and it waits for the FIN underscore wait underscore 2 message. In step number 3, step number 4, it will receive the particular FIN message from the server, and in the last step it will send the acknowledgement that I am successfully received the particular signal of FIN. So this is the case how the TCP is closing the connection. Now we are moving to next topic, that is all about the congestion control. So first question, why we require congestion control in our transport layer? So when we are talking about the sender and receiver different speed, at that time this concept will be useful. So congestion is refers to the network state where the message traffic becomes a heavy so that it slow down the network for the given response time. So congestion is one important issue here when we are talking about the packet switch network and we are talking about the reliability. So congestion leads to the loss of packets in the network. That's why it is then necessary that we have to control this congestion control with the help of different possible algorithms. Now we are moving to how this particular congestion control is working. So either it prevents the congestion before it happens or remove congestion after it's happened. So basically we can categorize into the two terminologies, congestion avoidance and congestion detection and recovery. So let's learn how this practically possible with the help of TCP congestion control. So TCPs react to congestion by reducing the sender window size. We already know the concept of window size in the previous video when we are understand the different window size in flow control algorithms. So we are maintaining here basically two window size, that is depends on the basically what we predefinedly taken. So it will categorize into the receiver window side and congestion window side. So receiver window side is maintaining where at the step number 1. When the TCP connection is established, at that time it will generate one message that I am ready to send the data and this is my speed and this is my window size. According to that window size, our data will be transferred without acknowledgement. So that's why we are maintaining here both two types of window side, that is the receiver window side and congestion window side. So let's understand how it will be working at the receiver window side. So receiver window size in the advertisement message, how much data, that is in the form of bytes, the receiver can receive without the acknowledgement. So here receiver should not send the data greater than the receiver window side. So sender must send the data according to that particular window side. Otherwise what happens here? That particular packets will be lost and TCP has to retransmit it. So sender should always send the data less than or equal to the receiver window size. And receiver reacts that the window side of the sender through the TCP headers. So when the header information of extend in the form of header, it will add that particular message, what is the particular size. Now understand what is the meaning of congestion window side. So here sender should not send the data greater than the window size, we already know, but here we are talking about the congestion. So congestion is all about the flow of the data. Otherwise what happens? Dropping the messages here. So sender should not always send the less than the data or equal to the congestion window size. So here different variant of TCP is using here. How to calculate the congestion window is used. So this approach will be, first we have to define how the congestion will be calculated, because congestion window is not predefined size. We already predefined the window size that the sender is accepting, but congestion is used when the flow over the speed and the particular data flow is not maintaining. So we have to calculate the congestion window size randomly with the help of the different algorithm. So here we can say that sender window size is equal to the minimum of receiver window size or congestion window size. From both of that, which are the less, that will be our sender window size when we are calculating the congestion window size. Now, what the policies are used to calculate the congestion window size? So for that, we have to understand three phases here: slow start, congestion avoidance and congestion detection. So that already I discussed how we can avoid the congestion and how can we detect the congestion. So first we understand the slow start mechanism with the context of TCP. So what is the meaning of slow start? So initially what happens in slow start? TCP is initially send the particular data items that maximum segment size here. So here maximum segment size will be decided by here TCP. So that TCP maximum segment size is 1 here. So in the first step, it will send only one segment, not more than one segment. After receiving the each acknowledgement, sender is increasing this congestion window by 1 MSS, that is your maximum segment size. So slow start, as the name, what happened? It starting with the slow flow and gradually it will increase the particular flow of our congestion window. So what happened in this phase? The size of congestion window will exponentially grow in here. So in the power of that particular 2 raised to, it will increase the size. So the particular equation for our congestion window size is congestion window size plus maximum segment size. So here congestion window size is in slow start initially 1 and plus we have to add our maximum segment size. So let's understand this scenario with the help of this particular figure. So initially particular my figure is telling that my MSS is 1 here. Now let's see here, after receiving the acknowledgement of first segment, what happened here? It increased the particular phase. So initially it can send maximum 1 size, but after receiving the first acknowledgement, it will exponentially increase and it will send 2 segments at a side. You can see here 1 and 2. After receiving both the acknowledgement here we can see here it is received both the acknowledgement. It will increase again. So what happened? It will send now in the exponentially form 1, 2, 3, 4. So it will send 4 segments now. So initially what happened here? It is send only 1. After receiving the first acknowledgement, it will send again 2. After receiving the acknowledgement, it will send 4, and after receiving the 4th acknowledgement, it will increase the size here. So we can say that in the slow starting phase, what happened? Each and every iteration, it will increase the size of congestion window. So what happened? After round 1, it will increase. So my size will be increased to 2 MSS. After round 2, it will be 4. After round 3, it will be 8. So that's all. The flow of that congestion window will be increased here. So this phase will be continuing up to some limitation. That limitation is known as my threshold value. So what is my threshold value here? So threshold is equal to minimum number of TCP segment that receiver window can accommodate, divide by 2 here. So here we have to take care about the receiver window again, because receiver window size will be decided during the first step. In the header information we are already sent that what is the receiver window size is the maximum size during the connection establishment. So we have to take care during the finding the threshold. If we want to find the threshold value, that will be a receiver window size divided by 2 here. So that equation is receiver window size into divided by the maximum segment size divided by 2 here. Now we are moving to the avoidance phase. So we already discussed congestion will be detected into the 2 parts. First, we are avoid to congestion, and second, after detection we are recover. So what the congestion avoidance is telling about? So after reaching the threshold here, sender is increase the congestion window linearly. So in the previous case, what happened? It is increased the exponentially in the power of 2. But what happened here? If we reach to the threshold, it linearly increases. On the receiving each acknowledgement, sender increments the congestion window size by 1 here. So this phase continues until the congestion window size becomes the equal to the receiver window size. So this is the avoidance case. What happened in the slow start? We already discussed. When we are reaching to some phase, that is threshold value, up to that we are moving exponentially up to the threshold value. When we are, that threshold value is the half of our receiver window size. But after the threshold value to the maximum size of receiver window, we are moving linearly. That means after the half of that threshold value, we are incrementing 1 by 1 here. So this is why the case of congestion window size, when we are trying to avoid that. That is the congestion window size is equal to congestion window size plus 1. And here my congestion window size will be my threshold value. That is the case here. We can see here, this is the first case of my slow start. Yes. Now, if I want to maximize the value of congestion, so what is my maximum value? That is my receiver window size. But up to the after the threshold value, we can say that it is increase in the linear fashion. So this graph is telling that from the 1 MSS to our threshold value, it increase in the shape of exponential. But after the threshold to the receiver window size, my graph is in the one line, that is my linear phase. So using this concept, we are trying to avoid this particular congestion control. The last topic is all about the congestion detection phase. Now understand the scenario. Congestion is already happened. So how can we recover? The first step is we have to detect that. So when the sender detects that loss of segments, it reacts that different way depending how the loss is detected. So for that case one here, detection on the timeout here. So what is the timeout here? The timeout is the timer expired before the receiving acknowledgement for a segment. So when the sender is acknowledged that my data segments are lost here, so in that particular case number 1, it is timeout before the timer is expired. So this case is suggests that the strong probability of congestion in my network. So there are chance of that segment has to be dropped in the network here. This is my case number 1. Now what the reaction is performing by the particular sender. So it's setting the slow start here again from the threshold value. So when we are talking about the threshold value is all up to the half of my receiver window size. So it decreased that point to the threshold value, and next it is up to this particular 1 MSS. So from threshold value to 1 MSS is trying to decrease the particular steps, and again it will use the slow start phase. So for the recovery, it is using the concept of in the reverse order. When the slow start is starting from 1 MSS to threshold, and again we are trying in avoidance, we are trying to threshold to plus 1. But when the detection is there, congestion is there, then it is perform the task in the reverse order. Now we are moving to the second step. That is the step is detection on receiving different duplicate segments, duplicate acknowledgements here. So what happened here? If sender receives the 3 duplicate acknowledgement for one segment, this can suggest that weaker possibility of congestion in the network. So there are the chances that the segment has been dropped, but few segments sent later after the reach here. So here what the particular our task will be performed after performing this. So if the weaker congestion is performing here, the setting is that slow start here threshold of a half of the current congestion window, and decreasing the congestion window size to the start threshold value here. So it is not back to the 1 MSS here. Okay. So if the weaker congestion is that, it is marked up to the threshold value and resuming this congestion avoidance phase. So in the avoidance, what happened here? What we are performing? In the avoidance, we are starting linearly. So our growth will be linearly. So according to this weaker congestion, the detection methodologies taken from this avoidance phase. So this is the all about how the congestion control is performed. So this is the last video of your TCP protocol transport layer. In that I already covered how the TCP's connection establishment and connection termination is working, what are the connection, when the congestion is performing, what are the problems will be occur. But now we have just seen the some terminologies which will be used in your examination. So that terminology is all about related to the performance. So let's understand one by one. First is about the bandwidth. So bandwidth is the characteristics of network. It can be measured in hertz and bits. How the data will be flows. So it is the one unit of the measurement of the data flow. Next is throughput. So throughput is all about the actual measurement, how the fast data can be transmitted in our particular using the bandwidth. So this is the measurement of the data transfer actually. Now next one is all about the latency. So latency is all about the term how the delay is performing here. So it is time required for a message to complete arrive at the destination from the source. So we can say that delay latency is divided into the four parts: propagation time, transmission time, queuing time, and processing time. So this all that terminology is already covered in the unit number 1 in detail. Next terminology is our bandwidth delay product. So when we are talking about this term defines the number of bits that can be filled in the links. So if my transmission communication link is there, so how much data I can fill? Maximum data, that is all about the bandwidth delay product. And the last terminology is all about the jitter here. So jitter is related to delay because we already know in transport layer number of packets are sent, and that packets at the receiver side, and that packets are received with the different time. So due to that, which delay is occurring because one packet is arriving X time, second packet is arrived at the Y time. At the receiver side, what happened? That packets are reassembled and then receiver will show that data. So due to that packet delay here, what the delay is considering, that is known as a jitter. So this is all about the performance particular or related to your transport layer. So thank you for watching this video. In the next video, I will try to cover your application layer protocol.